Hello everyone, welcome to Computer Science 215 Data Analytics Systems and Algorithms. My name is Gina Sprint. I am the instructor who designed most of the course materials for this class. This is an online class, so you will need to log into Blackboard in order to access many of the course materials for this course. The purpose of this video is to welcome you to the class. So thank you for deciding to take Computer Science 215. This is a great class. I'm sure you will enjoy it. The second part of this video is going over the course materials and the syllabus. So without any further ado, let's get started. The first thing I would like you to do is open up a web browser and navigate to this site that I have listed up here. I realize the font is kind of small, so I will show it to you here. piazza.com/wsu/fall2017/computerscience215/home. Now, some of the information you may see in this video and future videos may be different depending on the semester at which you are enrolled in. For example, this says fall 2017. For a future offering of this course, this may be a little bit different. So go ahead and navigate to this page. Once you get to this page, it should look something like this. It will look a little bit different because I'm the instructor for the course, so I have all of these edit options here, but it will look familiar. So Piazza is an online discussion tool with a lot of specific support for computer science classes. For example, you can post code and that code will be syntax highlighted. We'll use Computer Science 215 Piazza course as our main form of discussion. So I'll send emails out and make announcements through Piazza. There's also a really great Q&A feature of Computer Science 215 Piazza where you can post questions with your code and you can get those questions answered by your fellow peers as well as by the instructor or any TAs that may be in the course. There's also under resources another sub-tab called resources where I've listed out several great online resources for this class, such as these up here, as well as learning Python and data structures in general. So at the top of the main homepage, you'll see a description of the course, some general information. This information may change depending on the semester and who is going to be the instructor for the course. Next are the links to everything you need for this class. We're going to start with the syllabus and the course schedule, which is embedded in the syllabus, and then we'll make our way through these other topics here. But you've already seen the course website. That is this site you're on now. Down here is a link to Blackboard, which is important because this is where we will turn in assignments and the gradebook will be managed, and there may also be some course materials or links to course materials available through Blackboard. Lastly, down here, I would like to thank two open source projects, the Interactive Python project and NCWIT's Engage CS EDU database. I borrowed many materials from these two sources when designing Computer Science 215. I cited all of these great sources, and I hope that they are able to continue offering great resources for learning to program and learning data structures. All right, so go ahead and click on this link here under Syllabus and Schedule. This will take you to the syllabus, which looks like this. So as I said before, some of this information may change depending on the semester at which you're taking Computer Science 215. So let's start with course information. This is a 3-credit course, Data Analytics Systems and Algorithms. It is an online course. The prereqs for this course are listed here. Mostly what is expected of you being in this course is a strong object-oriented programming background from Computer Science 122 or Computer Science 132. Also, your math should be up to par in terms of discrete structures and calculus. In the description and learning objectives, I just want to hit up on a few things. This course is primarily going to be a data structures course. We're going to learn about trees, maps, hash tables, graphs, heaps, etc. But we're going to learn them in the context of data science or data analytics. But we're really going to focus on the data structures that are important for data analytics systems and algorithms that you may see in your future. We're going to implement these algorithms and data structures in the Python programming language. If you have not had the chance to work with Python yet, you're incredibly lucky to get to work with it now. Python is one of the top 4 programming languages in the world. It's actually number 2 in the data science community, depending on who you ask. It is my favorite programming language. It's really, really easy to get started with, and I think you'll have a lot of fun working with Python in this class. Next, let's move down to the learning objectives. So, analyze and apply core data structures and algorithms for data analytics. Design, implement, and test Python programs applying modern tools and techniques. In fact, the first 4 weeks of the class, we're going to focus on developing Python programs, learning the modern data science tools and techniques, including extracting, filtering, transforming, and computationally analyzing data. And this will also be sprinkled throughout the course. The ABET outcomes are listed here. Please take a look at them. This is an ABET certified program. Next, on to course materials. We've already seen the course website. That is the Piazza site. And next is course files. So let's take a look at course files. Course files is really a nice HTML view of a GitHub repository where all of the Computer Science 215 materials are hosted. So there are 4 subdirectories in this repository directory, CPTS 215. Lessons, this is where all of the lesson notes are going to be hosted. Micro assignments, these are conceptual and programming assignments that help you learn a new topic. Programming assignments, these are larger scale programming assignments that implement typically some form of a data analytics system. The project, we won't discuss that now, but once we learn all of the main topics in this class, there will be a culminating project at the end. The next 3 files, the syllabus, we were looking at that previously. Computer Science 215 Coding Standard. If you have taken a class at WSU before, computer science class, you've seen a coding standard. This document outlines the expectations of code style and organization for Computer Science 215. So any code for a micro assignment or a programming assignment, etc., that you turn in for grading should adhere to this Computer Science 215 coding standard. The last file here is a README file. This is for the GitHub repository. In fact, if you click in this upper right corner here, this will bring you to the actual GitHub site where you will see the repository for Computer Science 215. And here's that README file. In this class, we will learn about Git, we will learn about GitHub, and we will learn a lot about Markdown, and you'll understand more so what a README file is if you have not heard of GitHub and README files before. Okay, now we are on the course schedule. Make sure you familiarize yourself with this course schedule for the semester at which you are taking a Computer Science 215 class. This schedule will be updated with the assignment due dates. For now, this is a blank organized template. So each one of these rows represents a week in the course. So there are 16 weeks in a semester. So there are 16 rows in the schedule. Each one of the weeks is divided into a unit. So for example, the first unit is Python for Data Analytics. And this is the first 4 weeks of the class where we're going to learn some operating system commands. We're going to learn the basics of Python, and we're going to learn data science tools and techniques related to using Python for data analysis. The next unit is algorithm analysis, so talking about big O notation, how do we analyze the efficiency of algorithms in terms of time and space. We're looking at some sorting routines, reviewing several data structures you learned in your previous programming courses, as well as learning about hash functions, hash tables, and a map abstract data type. The next topic will be trees, and in 122 or 132, you covered trees, particularly binary trees and binary search trees. In this class, we will learn about trees and binary search trees, as well as self-balancing trees, AVL trees, B trees in terms of data science, decision trees, implementing our own decision tree classifier, and also how to visualize trees. Next, we'll talk about heaps, which is a data structure to implement a priority queue. The last unit is graphs and analytic systems. So we'll talk about the graph abstract data type. We'll implement the graph ADT, and we'll cover two very, very famous algorithms, Dijkstra's algorithm and Prim's algorithm for minimum spanning trees. We'll learn about Git and GitHub towards the end of the semester, which we will use for the project down here. And the last 2 weeks of class, we'll look at some fun case studies for data analytic systems that use some of the data structures we've covered in the course. And then lastly, we'll do project demos, and finals week have the final exam. So I've already touched on this, but for communication in the class, we'll use Piazza and Blackboard. When you are going to use Piazza, make sure that you do not post full code solutions. If you have a question about some code and you can share a small snippet, like 1 to 4 lines or so, go ahead and share that to Piazza. Students can answer your question. If it needs to be longer than a code snippet, perhaps the entire code base needs to be shared in order to get help, then post that to Piazza, but only privately to instructors. That way other students do not see your code. The textbooks we're going to use for this class consist of 2 required textbooks. The first is called Zybooks. The book is called Data Structures Essentials. It's a Zybooks book. It does cost money to subscribe to this Zybook, but it is worth it. This is an online interactive textbook, so you'll read a little bit and then you'll work through an activity to actively learn what you just read. This code will change depending on the semester, but let's take a look at what Zybooks looks like. So you'll go to the site zybooks.com, you'll have to make an account, and you'll enter the code, and it'll bring you to the Data Structures Essentials book once you pay the price in order to subscribe to the book. So there are 5 chapters in this book. For example, let's look at hash tables. So you'll read a little bit of text and then complete a participation activity. These participation activities, you can't get them wrong. So for example, question number 1, a 100 element hash table has 100 buckets is the correct answer. If you select items, then it'll let you know why that is incorrect, and then you can fix it. So this is a great resource, especially in an online class, to really get kind of the practice that you might get in a lab. This book is language agnostic, meaning there's not going to be specific Python examples. So this is just going to walk you through kind of the overview of the data structures and the algorithms in terms of the big picture concepts. One thing I will note about Zybooks is chapter 1 does have specific examples for different searching and sorting routines in C++, C, and Java. Not in Python, but that's okay, because in the lesson notes, I will go over the Python implementation of these algorithms. So whatever your background is, whether it's 121, 122, you can take a look at the C++ and C code to help you learn it. Whether your background's 131, 132, you can look at the Java code. to help you learn the materials. Okay, let's take a look at the other textbook for the course. This textbook is by Miller and Rainham of Luther College. It's called Problem Solving with Algorithms and Data Structures Using Python. It is a free open source book hosted on interactivepython.org. This one is Python specific. So this is a really great resource to brush up on your Python skills should you need to, and also see how to implement some of these data structures and analyze them specifically in Python. So in the course schedule, both Zybooks and the Miller and Rainham book have readings associated with each topic, and it's very important that you stay on top of the readings, especially for Zybooks, because part of your grade is based upon it. Supplementary textbooks, these are not required, however, I recommend them. Python for Data Analysis by Wes McKinney. This is a fairly reasonably priced book on Amazon. Looks like it's about $30 at the time of this recording. Definitely worth it when we learn about the basics of Python and the Python numerical analysis and data science libraries. The next one is How to Think Like a Computer Scientist by Downey. This is also a free textbook hosted on interactivepython.org, the same site as our Miller and Rainham book. Now this one is not data science specific. This is just going to cover all of the basics of Python, and this is going to be really great in the beginning of the course if you could follow along in this textbook as well. And there are more resources to learn Python and data structures listed on the course website under the Resources tab. Okay, next you are required to have a laptop for this class for accessing Blackboard, Piazza, and the course materials and completing your programming assignments. To complete your programming assignments, you will need to have Python installed on your machine. We will be using Python 3 in this class. I recommend downloading Python 3 from the Anaconda 3 Python distribution. This is important because the Anaconda Python distribution is a scientific distribution. It includes many of the libraries we're going to use in this class. So you won't need to download them separately if you just download the Anaconda 3 Python distribution. So the installation instructions are here and the download links are here. It is available for all major platforms. One thing to note about platforms for this class is you may use any operating system you like, Windows, OS X, and Linux, because Python is in an interpreted language. It's not compiled, so Python will run the same on every single one of these operating systems. The examples in class will provide usually Windows, but sometimes Unix-based, which is OS X and Linux-based examples. I encourage you to work on a Unix-based machine. It's great practice, but either Windows or OS X or Linux will be just fine for this course. Now the part that everybody probably is most anxious to hear about is course grading. How do I get an A in this course? Well, let's scroll down to look at the assignment weights, and then we'll come back and look at each one of these assignments individually. So programming assignments, worth 25% of your grade, micro assignments 20% of your grade, the final project worth 10% of your grade. The Zybooks participation activities that I showed you in Zybooks are worth 10%. As long as you work through those, this should really be the easiest points, okay? But Zybooks is a great resource to help you learn, so don't just click through the activities. And the exams were 30%, 2 midterms, 10% each, and 1 final, 15%. And here is the grading scale here. So there are 6 programming assignments. Most of them have a data science context, and they must be written in adherence to the Computer Science 215 coding standard, which I showed you. Programming assignments are to be completed independently. It is easy to get code sharing. Don't do it. There is an entire subsection at the end of the syllabus on the Computer Science 215 academic integrity, plagiarism, and cheating policy. Please read through it. This applies specifically to programming assignments. You're going to upload your programming assignments as zip files to the corresponding assignment portal in Blackboard. The course schedule will have the assignments and due dates. Micro assignments are similar to programming assignments, but smaller and may also incorporate conceptual questions instead of programming questions. Same rules apply for submitting micro assignments. Micro assignments, some of them can be completed together. If you do work with another student for a micro assignment, make sure that you cite the student that you worked with in your top level comment block in your code, and make sure that you are responsible for knowing all of the material in the micro assignments. Very important. The final project is going to be in groups of 2 in pairs to implement a data analytics system in Python. We will cover that more towards the end of the course. Zybooks textbook reading. There are participation activities in the Zybooks textbook worth 10% of your grade, and exams, of course. Even though this is an online course, I do not specifically allocate a certain percentage of your grade for participation in online discussion forums such as Piazza for this class. But you are expected to regularly participate in Piazza, and it may help your grade at the end of the semester. As far as the rest of these policies, I'm not going to read them to you. It is your responsibility to read through this entire syllabus and know it inside out. This is the contract between you, the student, and the instructor for this course. So make sure you read through all of the rest of the details in this document, particularly the Computer Science 215 academic integrity policy, what constitutes working with a team member when you're not supposed to. This is all listed out here, including some example scenarios from Aaron Crandall's Computer Science 223 syllabus, which are really great to read through. Final notes, if you are in Pullman, there's free tutoring for students in computer science. There's a link here to that offering. And of course, my advice for being successful in this class is practice, practice, practice. You've taken computer science classes before. You know that you don't learn to program by reading about programming, by listening to someone tell you how to program. You really have to have your hands and your fingers on the keyboard. It's very important. So my advice is to keep practicing, absorb and read and practice with many different sources. So the lesson notes for this class, the videos for this class, Zybooks, the interactive textbook from Miller and Reyna, as well as resources online. Make sure you take advantage of many different channels to learn this information and spend enough time on the course and you will be successful. So with that, I will wrap up this video. Once again, welcome to Computer Science 215. Very glad that you're taking this course. And this was an overview of the course materials, the website, and also the syllabus.